Hello. So I've been asked about the modifications I did to the speed regulator. Well, I already did a video about it, but I have made further modifications and I'm planning to make another iteration with another one. So to understand it, let me first explain what are the constraints and how it works. First constraint is very obvious. The speed regulator is just below the main board and the baseboard, so you cannot modify the height. It's just tucked with very little space to spare on top and on bottom. How it works? Well, first the electrical part. You have one cable coming here, one ring, another ring, and one cable going out here. Uh, these rings are connected with two brushes. Those brushes are connected between them, but not with the body. Okay. So what happens? Here you have the rings. You see one cable goes to the upper ring, the other cable goes to the other ring. These brushes rides one on top and one on the bottom. When the speed regulator goes too fast, they go down until one of them touches this middle part, loses the electrical contact, so the motor slows down until it goes up again and starts again making contact. This causes a lot of sparks because these are, let me show you the old version of the, here it is. Okay, you see they're very thin stripe, copper stripe, and they have the lifespan is about a couple of hours. So the first thing I made is to change these brushes for brushes from an electric motor. For example, electric motor that you can find on a slot car. And they have a carbon brush, so the lifespan is hundreds of hours with much better contact, also electrical contact. Okay, this is the electrical part explained. Let's go to the mechanical one. So what you normally expect for a speed regulator is that let's show you. Let me show you one. When the speed increases, it expands, and the lower part goes up and down. Okay? Here is just the opposite. Instead of being this part that goes up and down, what goes up and down is this part. How that's possible? Because this lower part, in this case a pulley, this part, is held with a collar. So this can only rotate but not move up and down. And this part here is free. So when this expands, this goes down and drives the brushes down. To fine tune this, you have an additional spring, that is this one you have here, with a rod that goes inside the shaft, because the shaft is a tube, until it's connected with this other collar. So you, by screwing or unscrewing this nut, this goes up and down, and this spring compresses against this part. So you add the tension of these springs to the tension to this one. Okay? But if one weight is a smidgen more heavy than the other, or this spring is not exactly the same length or the thickness or whatever, or the curve or whatever, you end up with this part moving sideways a little bit, and it's brass against brass, so it binds. You can minimize it doing what I did, modifying, for example, this upper part of it. Here you can see this is a solid part. What I did it in two pieces. This is brass and this is tuffnol, sort of bakelite. So it moves much smoother. But what it should have, and that will be my next iteration, is to put this tube here. If you ever wonder why this has a tube here, is to make this surface much longer, so the possibilities of binding going sideways are minimized. So this moves much more smoothly on the shaft. So what I will do is to do this piece here with a tube here, okay? And the only other modification I will need to do is to, sorry for all this movement, if I put a tube here, this spring will have to be a little bit wider, and maybe also this collar be a little bit wider to accommodate the wider spring. And that's it. So my next iteration will have that, and the final version of all the 10 units I'm going to make will have this modification also included. And that's it. Thank you very much for your patience. Bye.